Hello and welcome to this press conference about the Haiti and Chile earthquakes and tsunami. And I want to introduce to you Massimo Cocco from Rome, Italy, Vasily Titov from NOAA in the US, and Raul Madriaga from Paris in France. So Massimo, I believe you want to start?
Yeah. Yes, I would like to start by introducing these two events, which were produced a huge mediatic and societal impact. So there are several peculiarities that make this event important for the scientific community and also for the actions that the stakeholders and the governments and the international community must do in order to mitigate these effects. And mostly they are different, but at the same time they point out the need of actions for prevention. And while the Chile earthquake is relevant both for the earthquakes and for the tsunami, maybe the tsunami is even more important because there was, as my colleagues will explain later, there was a lack of alert by the national government of the tsunami. And also for the earthquakes, which is in any case a very large magnitude event. And Chile, despite has been studied for a long time with the temporal experiments, with international cooperation, French, English, EU, Americans and Europeans, installed networks and studied. Indeed, we know pretty well the subduction process, the source and the geometry of the slab in that region. The lack of permanent infrastructures for monitoring and for providing not only real-time data, but also the proper contacts between the governments and the stakeholders and the scientists, and then the lack of educational and outreach activities produced a lot of problems immediately after the earthquake. And while Haiti is a paradigm because it was a catastrophic event in a well-known seismogenic zone, and my personal opinion is still the scientific community and the international cooperation is still not able to provide any support to this area in the world. So after Sumatra and after Haiti, I think that it's time that we should ask if the intervention from most developed countries must involve in any case and cooperate with the local institutions, and if the level of scientific development in that area is not enough, we must promote, because the only way to promote mitigation and prevention action in these countries is by involving the local authorities and the local scientists in this process. There are no way to produce perfect and marvelous seismic hazard and risk global maps in the developed world, put this in the website or also by international organization, and just hoping that they will be used and applied in the less developed countries. And I personally believe that this is one of the key lessons from the Haiti. So, but the two earthquakes were peculiar also from a scientific point of view, both for the tsunami and for the earthquake, and I believe that Raul Madriaga and Vasily Titov will explain better the details and the state of knowledge of these events and what we can do in the future to avoid that these events will produce these natural events, because we have to remember that we are speaking of natural events that will repeat in the history, will produce again this catastrophic impact on the society, on the environment.
Where do you go next? Continue on this earthquake.
Okay. Well, I'll just show the general situation so that no, it's the second slide. That would be enough. So this slide shows the situation in Chile right before the 2010 event. Chile has lots of earthquakes that occur pretty much regularly. Every 10 years or so we have a magnitude 8 earthquake. And in this century we've had 3 very large events: 1922 in north central Chile, 1960, which is the biggest earthquake that has ever been recorded instrumentally, and now the one that we had this year in February. Studying the history of Chile, it's interesting because much of the development of the settlement by Spaniards in Chile was guided in great part by the earthquake activity that started almost immediately after they arrived in Chile. And in particular, the city of Concepcion is very important because this is the second largest, well, the third, in fact, largest populated area in Chile, and it's a center of industry. The city itself was destroyed by 3 earthquakes in history, and the most important one occurred in 1751. At that time, they decided to move the city that was on the ocean side to a place that is inland, near the river, because every time a large earthquake occurred, the city was simply swept away by the tsunami. It happened again because the ancient site is called Penco. It was again completely destroyed by this event. Yet the city itself sustained very little damage. Unfortunately, there are not very many places where you can put cities in Chile, so they built it on the riverside, on a very soft sediments, and so the earthquake produced a lot of effects in the city, although most of the buildings resisted. Now, what we've done, I don't think we need to go into great detail because it will be too technical. What we've done is to study this event with all the available data. There are 3 important steps in this. In the late 80s and beginning of the 90s, a group of Chilean seismologists in some ways corrected the common knowledge at the time. And it was that this place had broken in an earthquake that occurred in January 1939. That's a very damaging earthquake with 20,000 people died in Concepcion and Chillán, which is the region of this city. And that event was so dramatic that, well, when people studied Chilean seismicity, they thought that this zone had already broken. And at the beginning of the 90s, it was discovered that it didn't. And then in the late 90s, starting from 95, the European community supported our work, and we deployed a set of instruments in this region, what we call the gap. At the time, we thought only the 1835 zone was going to break. It turned out that the earthquake was bigger, and luckily we have enough data to understand the earthquake itself. Then from 2000 to 2010, we deployed a number of instruments that unfortunately were not well maintained because there is no national, I think Massimo already referred to that. Chile has no national seismic network. There's only a small network maintained by a department at the university in Santiago, but there's no national organization that takes care of earthquakes, and this has proved to be a big embarrassment, mainly for the government, because 6 hours after the earthquake, they couldn't tell the population whether a tsunami was going to occur, although the tsunami had already occurred. So only the national radio nets, which communicate by radio, could get the information, and the government could not get any information because all the telecommunication infrastructure was down, and especially the big problem is people using telephones because they saturated the national network. So this was is still a big problem, and I don't know if it's going to be solved, because we are now expecting other earthquakes in northern Chile, where the last one occurred in 1877. And this place is, we consider it to be extremely dangerous now, because it has become active in the last 5-6 years. And so it may have a future earthquake in, let's say, 10-20 year time. So that's the main story of earthquakes in Chile, and my talk was a little bit more technical, is the fact that in spite of the size of this earthquake, many people that work on earthquakes had suggested that a magnitude 8.8 earthquake would be devastating for Chile. And Chilean engineers, I'm an engineer by training, we had this develop extensive technology, and we have a national building code that is supposed to be able to, so that buildings are able to survive large earthquakes. The Chilean code is designed in such a way that no building should collapse. And this was very well respected. I think that this is why we only have 450 people killed. Most of them because of poor warning for the tsunami, and that, as I said before, because we didn't have a network, the government could not announce the tsunami. But the buildings resisted well, and all the modern buildings, including very tall buildings in either Concepcion or Santiago, survived well. Only one building collapsed in Concepcion, basically because they didn't do the proper job in improving the foundations. But other than that, there are some damage to structures. For instance, the airport had to be closed for almost 2 weeks because all the air conditioning fell and so on and so forth. But the building stood the earthquake. So the basic consideration in the Chilean code is that it resisted. Thank you.
If you wish, okay.
I'll show maybe a couple of slides, but not too many. That's this was the technical presentation, not intended for the press conference. So just maybe as an illustration, but I'll focus on the story of tsunami for the Chilean earthquake, which really extends this event beyond the Chilean border, because tsunamis are such a phenomenon that they do export the damage beyond the immediate earthquake area. And while most of the destructions from the tsunami and all the people killed were in Chile, within the Chilean border, the story of tsunami went beyond just Chile, and it was actually the first basin-wide, what we call tsunami event since Sumatra, which by itself made it an important for at least the tsunami scientific community, and that's where I'm coming from. I work for NOAA, but I'm in the research part of NOAA, and we're developing forecast system for the operational side of NOAA, which are tsunami warning centers that U.S. tsunami warning centers. There are 2, and one is also serving as an international Pacific tsunami warning center. That's the one in Hawaii. So this event was then the opportunity for, at least for the scientific community, to compare how far have we improved the system since the Sumatra 2005, because that definitely triggered the very active development of the tsunami forecast system and tsunami warning system. And in contrast with the event in 2004, that's when Sumatra occurred, at the very end of 2004. The Pacific-wide tsunami that was generated by the Chilean earthquake was monitored and forecasted pretty well, pretty extensively. It was, in some way, it was the first tsunami that was sort of watched real time, at least in the United States, and that was both the curse and the blessing in a way, because we were under the tsunami warning system was definitely under the magnifying glass of media all the time, and at least in the United States, while the forecast and warning worked just as what we call as designed, the transmission of this information to the public had a bit of confusion, and we're trying to learn the lessons from that. One of the confusion is that historically, the scientific community has always focused on this, what we call holy grail of tsunami warning and forecast, when we want to predict tsunami amplitudes accurate enough that the warning can be pinpointed to the specific communities that are in danger. And in a way, we succeeded. And this success was also a curse, like I said, because we've focused so much on these amplitudes and these wiggly lines that we're very proud of when we're showing that the comparison is so great. But then when this information, for the Chilean event at least, at least for the United States, when the damage was not large, but the impact was substantial enough that it caused some damage and some confusion. And when Tsunami Warning Centers was trying to convey this forecast information that was really done the first time in operations, the forecast system that we've developed is now what we call in pre-operation for the Tsunami Warning Centers. They were focused so much on these amplitudes and wiggly lines that public was thoroughly confused on what exactly Tsunami Warning Centers were talking about. And then when Tsunami Warning Centers were talking about 3-meter waves amplitudes, the information that was conveyed to the public for it in Hawaii was that everybody was expecting 3-meter high waves coming to Hawaii. Beaches were evacuated, which was a right call, really. But since all the public was really expecting 3-meter waves, which never came, and that 3-meter was a peak to trough amplitude that scientists did not bother to explain to the public, and so there was a bit of a confusion. So that which triggered us to thinking that the transmission of tsunami warning information to the public and to the warning recipients should definitely be changed in the future tsunami warning centers, in the future tsunami warning system. And instead of focusing on the amplitudes and this, these curves in comparison that we scientists are so proud of, we should probably focus more on I'll just skip that, more public friendly, if you will, products, and maybe something like that. So instead of saying that, in text messages, which is still being done, just like 40 years ago, when tsunami warning system was initiated, and there was a lot of text messages that was sent out to warning recipients, saying when the tsunami is going to come and potentially how large. Probably the graphic products like that, I show here, that can be sent everywhere, including tsunami, including cell phones, actually, can explain the warning information much better than text messages and talking about the amplitudes and explaining what these amplitudes are and where these amplitudes needs to be observed. So that's the real lesson, at least for the scientific community. Of course, there is the human part of the story that Raul probably knows much better, because there's definitely a tragedy. Many people died, and the local tsunami warning is a different story, which I can't really comment much because I still don't know. We don't have much information from the Chileans, and we're hoping to work with them together on improving the system, because again, tsunami warning system can be only efficient if it's an international by nature, and that Chilean earthquake and tsunami definitely illustrated it once again.
Thank you very much, Vasily. Are there any questions from the room?
Hello, Jonathan Amos, BBC News. Where shall I start? On the tsunami. I mean, of course, in terms of warnings, the people closest to the event, the only warning they will ever get is the earthquake itself. And then that's down to education, is it not, as to how they react to that event. But I wondered if you could just give us some numbers on how the tsunami affected the basin, how long it took to, I don't know, get to Hawaii, to Japan, what sort of impacts we saw at those locations. Amplitudes even.
Sure. No. I should have mentioned it first. But you're absolutely right. The forecast system that we're working on, that we developed, works very well for the what we call far field events that so meaning for the locations that are fairly far away from the source. That we consider this problem is really in a very good hands right now. The local, what we call the local forecast problem, is definitely a huge challenge for the community, simply because of the time involved, and that the tsunami, taking Chilean tsunami as an example, it arrived at the closest coastline in about half an hour after the earthquake, which may seem to be quite a bit of time to react, but if you consider that in half an hour, if some actions are to be taken in half an hour, which would include evacuation of quite a bit of people from the coastline, that's not a trivial accomplishment. Half an hour is very little time. So you're absolutely right. If the public is not educated enough to act on as little information as possible, and all information that's available, that includes, of course, the shaking of the earthquake itself. That's a very difficult problem to solve. So it's definitely, and we had a very good discussion yesterday during the meeting when we realized that only when you take all the efforts together, which include education of the public, developing forecast system, government response, and the local response, only then you can have an efficient system that can save life, that will save life for the coastlines closest to the earthquake epicenter. Because forecasts and warning can be only efficient if it goes to the educated public that knows what to do. If it goes to the people that have no idea what these messages are all about, you would, whatever scientific knowledge and scientific accuracy will have, it will be not used. So that's the bottom line. I think we have the science now to do the forecast and to provide pinpointed warning, but then the whole system needs to be a combination of educational efforts and all the science that we can do.
Can you just give us some numbers in terms of local impacts, run-up? I don't know. Sorry, Dick. Just some numbers on impacts from local to far field. Right.
The local impact is still being assessed. By the way, there are many teams measuring, how high the waves were locally. But what we know, it's at least 10 to 15 meters. That's the vertical, what we call run-up, the vertical extents of the waves that went inland near the epicenter, locally in Chile and islands of San Fernando, Juan Fernandez, were also impacted pretty well, but I don't really know what the wave heights were there. When it propagated further away, I know that there are impacts along the South American coastlines also, but we don't know the numbers there yet. In far field in Hawaii, there was we know that very well because that has been assessed pretty well. There was a minor inundation there, which first of all Hawaii decided to evacuate all the coastlines based on the information, and there was the right call in a way. They do things because in Hawaii the procedures are that if there is a threat for anywhere in Hawaii, they evacuate the whole state, and there was clearly some impact expected in at least few locations in Hilo and Kahului. So when they looked at the numbers that were forecasted, they decided that definitely warrants evacuation, and they called the evacuation for the whole state. and that was, so in Hawaii, the waves, the amplitudes were, again, the amplitudes, meaning that what the waves that were recorded on the tide gauges were up to about a meter high, and peak to trough it was about 2.5 meters or so in several locations, but not everywhere. Say in Honolulu it was much smaller. In Honolulu it was I think up to half a meter, so it did not penetrate into land at all. But it did create quite a bit of currents, and we've seen that in pictures and some assessments. So the impact was expected. That's why people were evacuated. So everybody was safe. I mean, that was the right call. If I was a tsunami emergency manager in Hawaii, I wouldn't want people to be in the water during tsunamis, and the only way to do it is to evacuate it from the beaches. On the west coast, the impact was actually comparable, a little smaller, but it was still recorded, and no inundation was, during the tsunami, was recorded. There were some interesting events one day later in California and in the west coast of Oregon and Washington, where people saw some inundations, and we're still evaluating was that related to tsunami or not, but it was an interesting, at least coincidence. Probably it's not coincidence, but that was something that we did not expect. It was, some flooding events were reported 2 days after the tsunami, during the high tide though. So we're still exploring if that's the waves that may be reflected from Kamchatka and Kuril Islands that came back to flood some coastlines in the U.S.
And just to add to that, the time to Hawaii was.
It's let's see. Well, it doesn't say how much. It took, as far as I know, there were some. See if I can get. Well, I think it's about up to 18. Well, 14. It's more than 12. 14, 16 hours to Hawaii. So it's for Hawaii. It was definitely plenty of time to make decisions in evacuation. An evacuation decision in Hawaii was made at least 6 or 7 hours before tsunami arrived. And tsunami arrived early morning on Saturday, which made evacuation much simpler actually for Hawaii. And that was probably part of the decision making too, because Saturday morning they decided not many people are going to be in the beaches anyway, so why don't we call evacuation? And so in many different respects, I think it was definitely a right call from my scientific standpoint.
And that 83% accuracy, what do you mean by that?
Well, that's exactly this. The 83% accuracy relates to the model estimates of the maximum amplitude computed at at different locations, including Hawaii, several locations in Hawaii. So the amplitudes that we forecasted, when you take the average and do some math, that produces about 83% of the actual measured amplitudes at the tide gauges. Since the only way we can assess, we really want to assess how accurate our forecast system is, and the only way to assess it is to compare it with actual data. And the only actual data we have from tsunami is from the tide gauges. That's why we focus so much on the tide gauge and then the accuracy there. But again, conveying this to the public should probably not focus on the tide gauges, because tide gauge is really a scientific tool that we use now, we use to assess our accuracy. The impact that we forecast is forecasted for the whole community, and that's what we decided that definitely we need to shift in paradigm in that tsunami warning information.
Holger Cocco, German media. So what do you have to combine to the tide gauges? Do you have to combine topography, or if you want to make these alarms of inundation?
The tsunami forecast includes modeling of tsunami dynamics from the source propagation across the ocean and the impact at the coastline, and that includes it's fairly sophisticated models that use different kind of data, seismic data, a lot of seismic data, a lot of tsunami measurement data in the deep ocean, and tide gauges are really used for testing our forecast. against the data, to assess the accuracy, because tide gauge already records the impact of the tsunami at the coastline. So to do all that, to combine all the data and model it, we need pretty accurate what we call bathymetry, which is topography of the ocean floor near the coastline, and a lot of data of tsunami. And the more data, the better. Scientists will never tell you that they have enough data. We'll always need more data. But the main components are, the seismic the data about the source, which usually comes from seismic data. Then the most important information for the accuracy is the measurements of tsunami in the deep ocean. That gives us very good information about the tsunami itself. And then to assess the accuracy, we need the tide gauges and the model at the tide gauges, which require very accurate bathymetry near the coastline.
So, I mean, in kind of summary, I guess an example would be if no, that's probably not right. But I mean, in summary, we've got an event which could have been a lot worse in terms of its impacts, but still, the infrastructure really does need to improve so that some of these messages, some of the education, some of the first time information is able to be distributed through Chile. Yes, I mean, is that kind of where we're at? Yeah, we were fortunate this time in some ways.
Yeah, you refer to Chile?
Yeah.
Oh,
The situation.
in some ways, yes, because the damage of the earthquake is very difficult. If you measure damage in terms of lives, it's very small. But if you measure it in terms of damage to Chilean economy, it's about conservative estimate is about 30 billions. Compared to the package that Europe is providing Greece, it will be about the same size. And Chile has about the same. It's a bigger population, and it has a income per capita which is similar to any Eastern European countries. So it's a major shock, and the government is now suffering because in some ways, because there weren't a lot of people that died, the international help has been extremely scanty. European countries in particular were not very generous. And Chile has now a lot of big problems because the winter starts, effective winter starts around this time of the year, so that temperatures go down to about 0, and it rains almost continuously in this area. And there are still about, nobody really knows, but anywhere between 100,000 and 500,000 people that are homeless. So it's a very, very, very major problem, and international help has simply dried out because there are many, many other problems going on in the world. So there's a big debate in Chile nowadays about the efficiency of the government to take care of it. And the new government is suffering from that.
I can add also one further issue, which on the media, immediately after the Chilean earthquake, one of the biggest news, despite we were still understanding if the tsunami occurred or not, was the actions of the population that were just entering in the town, and thefts and other damages to stores and so on. And these images went around for days. And this is just the effect of the lack of proper communication with the population. If you simply leave the population alone without provide any information what will happen, and even if what you will tell is not the truth, because what happened in Chile, they said there is no tsunami, but in Concepcion they knew very well that tsunami there was. They are only 30 kilometers from the coast. So, and this is just a reaction. So there are the economical costs also include the social costs that is not easy to estimate in terms of GDP, but it is crucial. And this is again means that during a peace period, which means far away from catastrophic events, you have to build up awareness on these effects. So this is what we are doing in the developed world, even if with some delays. And the challenge for the future is how to do this at global level in the developing countries. And to do this, we don't only need the scientific motivation, which is already existent. For instance, in Chile, also because Chilean scientists are quite well, good reputation and well established. So, but what we need is a common political action in order to promote this kind of integration. Is the only way. And again, you can make a comparison with Sumatra and Haiti. And in Sumatra, despite the huge investment for science, there is no awareness of the tsunami. What happens in the 2006 for the tsunami was just the opposite that you would expect for the same population that experienced the 2004 tsunami. They went to the beach to see what was happening. So, and we are more or less in the same condition. And this is a serious problem, and scientists alone cannot do nothing. So we need too many actors to play this game. And this is the very, very sad lesson from Haiti, where I don't know how many international cooperation and helps they just sent immediately after.
It is still going on.
Yeah. And honestly, in Indonesia, the shock was also caused that there were a lot of Europeans there. So the question is, how would be the reaction if there were no Europeans there?
Another cynical question. Any more questions? Then I think we will finish here. Thank you very, very much.